Okay, this here is what we call the pi problem. What this simulation is also what the Monte Carlo simulation is. You try to approximate pi, which we all know to be 3.14159, etc., 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 because it's never ending. But usually people use 3.14 in schools, what we've always used. So, but here's how to actually derive that number. Okay, say if you take a circle and inscribe it in a square. Circle has if you inscribe a circle of radius 1 inside of a square. Inscribe means you perfectly put it inside a square where the edge of the circle touches the edge of the square. Then you would get a square with a length of 2r. Right. Now, the area of this square is 4r squared. Now, we know the area of a circle is pi r squared. So if you divide the area of the square by the area of the circle, you would get 4 over pi. Now, if you multiply this number by 4, you get pi. If you have an understanding of that. I also call this in Visual Basic of Excel. And the point of this here is that at first the number will be, the pi approximation would be high. It'll go like it'll go up and down, and then eventually it'll settle out at 3.14. As you can see here, and I've run this 100,000 times, which you probably need more times than that to actually get it to where you need it. See here, it's like a 3.15, 3.14, but you have to run this a huge amount of times to get the number you need. Right now we're only at 15,000, 16,000 times. But eventually, whenever it finishes, you'll see the graph here develop. So right now we're at 3.14. 5, 6, 2, 1, whatever. You'll keep doing this for a long amount of time to actually get the actual pi approximation, which is basically the probability of the, and the idea behind it is if you pick random points between 0 and 1, which is x and y is between 0 and 1. What is the probability that they'll land in a circle? That probability equals 4 over pi. If you divide that by and multiply that by 4, you get pi. So if you just pick random points, which is what we're doing, to determine that if it's inside of a circle, of course you use the x squared plus y squared equals, if it's less than or equal to r squared, then it is inside a circle. That is the math behind it. If it's not, of course, it's not inside the square. It's just only in the area of it's not inside the circle. It's only in the area of the square. So, yeah.